Hey everybody, my name is Indraneel. I work at SharedStreets, um, and I want to thank everybody for coming out actually, and thanks to the organizers for putting this on because this is a really cool event. Um, and yeah, I just want to start by saying this is not about like sense, trains or anything like that. As the name suggests, SharedStreets is actually we focus more on the road network. So yeah, I'll be talking about SharedStreets as a whole. I'll be talking about road closure data specifically. And hopefully you can leave here with an understanding of what it is SharedStreet does, our sort of application stack that you can build on top of, and the road closure project specifically if you happen to work with that. So what is SharedStreets? So we're a nonprofit, and we oh, closer. Sorry. That makes sense. We're a nonprofit. We work on digital tools for helping facilitate data to be transferred from cities to private companies and vice versa. And who is Shared Streets? There's a grand total of 5 of us. No one else could be here today because everyone's all over the country. We're completely distributed. So if you've seen that tweet with um, the video call bingo, we get that every single day. Just no one, I mean, a lot of awkward pauses, but we make it work. Um, and to talk about why I ended up at Shared Streets, I've been here for a little under a year. And actually, I worked on a similar product myself with a friend of mine, Ricky, who's actually here today. And we built a parking management tool. Um, and one of the things I noticed sort of straight away was I'd have to do a lot of work to sort of repeat. I have to repeat a lot of work to get the tool running in any city I was in. I did a pilot with the city of Asbury Park in New Jersey, and I had to write that SQL query, which you can't read, but neither can I. And I don't. I mean, I wrote the thing to just to get like when you click on the little lines on the streets, just to get like a UI thing where you click on a curb and you get like the full length of parking meters. And I was like, this is completely untenable. And the data, and there's more stuff we had to do that is not here. We had to clean the data. We had to work on getting it to like be in the right format. And so I was thinking like there must be a better way to do this kind of stuff. And it turns out Shared Streets is actually working on a lot of things that enable this kind of data analysis. So we work on a lot of different areas. We have several pilot projects in flight at the moment. So from just going row by row, map conflation, construction closures, TNC pickup drop off, mobility metrics, which is like micromobility, curb inventory, which is very hot right now, and speeds and safety. These all kind of use the same core technology under the hood, but they're all very different areas, and the applications they vary quite significantly. I work on construction and closures, so that's what I'm mainly going to talk about today. So the um, the road closures are very difficult to communicate across apps, and cities need a way to express road closures authoritatively. So this I just Googled road closure. I think incorrect, or not. I didn't Google it. I went on Twitter and searched for it, and I found this tweet from, I guess, the Travel Association of West England, like the Bristol area. If anyone is familiar, I'm not. And they tweeted out this photo saying, "Oh, the road closures that we have on Google Maps are all wrong. It's not 24 hours. It's only like certain hours. These roads are open during the day." And this is like, I mean, this is a very easy example to find, surprisingly, but it kind of speaks to the problem, which is that it's very difficult to communicate this information from like the city to the variety of maps and apps that exist. And that sort of presents a problem when it comes to very important things. I mean, I don't know about any of you, but like ever since I started working on this project, like when I see a road closure, I'm like, oh, I get the like, value of it because they really are everywhere. They happen a lot more frequently than we would think. They occur almost daily, almost everywhere. Cities know the closure locations, times, and durations, which is like a good thing. And data formats like CIFs do exist, but they occur more regularly than a typical update of the street network. So what that means is this seems like the kind of data set that might need to be produced with more regularity than just updates to like the core base map. And since they know when when the closures start and end, they need a way to express that information. one of the things, if you happen to go, I mean, if anyone's familiar with OpenStreetMap, one of the problems that sort of comes up with including road closure information in OpenStreetMap is that it's something that you might remember to put in because you'll see it, but you may remember to you may forget to remove that information. So it's a lot more transient. It's a more transient set of data. But again, the thing is that the cities actually do have this information at the core. Like they're sending somebody to go do the construction. They're issuing a permit to the construction or engineering agency that's handling this thing. But the problem is they need a way to express that information authoritatively. They need to say like, hey, we're the city and we're saying that this road is closed. And this problem actually persists across, it's very similar to what we're doing in our curb work as well, which I won't be talking about at length, but curbs exhibit the same properties, which is that it's a little bit different than other sort of like open government data. It's the law, it's rules that sort of apply to everybody. And so we kind of need, it's something that doesn't lend itself as well to being crowdsourced because it's not something that, it's something that the cities do ultimately own. Finally, like data formats do exist. SIFS is the big one. But the problem is the tools are like very specific to the consumers of that data. So that's something that we thought would be an area to improve upon. So to leverage that data format, but to make the tools sort of agnostic to who's consuming that information. So our solution is an open source web app to create the data. And to start with, we focus on cities that don't have an existing like GIS process to produce the data. So some cities, like they're very advanced in the way they approach these things. They've got GIS teams that work on this on road closures, and they're maybe already producing a data set. To start with, we didn't focus on them. We're probably going to turn our focus to them now. But we did notice, and we did speak to a few cities / government agencies that don't really have like a strong GIS workflow around this. The Port Authority of New York, New Jersey is one of them. So we're working with them pretty closely in sort of building this out, and they've begun using this to produce data across all the different platforms that they communicate with. And that's sort of the second point, which is that the tool creates data in common formats that make sharing easy. So right now we support GeoJSON and CIFS. CIFS is like the closure information feed specification that Waze has sort of made open to everyone to use. And GeoJSON, if you're unfamiliar, is sort of a standard way to share geospatial data that's emerged in the last few years. And we're also like looking at future formats as well. The US DOT is working on their own work zone data exchange format, and we're sort of seeing how that progresses and hoping to integrate that as well, depending on how things proceed there. And for anyone curious, this is really more specific to OSM, but if you're familiar, if you're not, I apologize. SharedStreets reference IDs, which I'll explain in a little bit, can be linked back to the OSM IDs themselves. So the data is sort of like backwards compatible in that way. And we sort of have taken care of a lot of the graph normalization aspects of this work. So you don't have to worry about that stuff within OSM. So this is what the application looks like. And I have a demo video, which I thought would be better than flailing around on here. So it's pretty simple, and that was sort of the goal. This is me closing, I guess, the street right outside and doing it, I think, for the month of September. And the data that gets produced on, like in totality that we'll see as I scroll down. Oh yeah, so we're having a parade all month. So basically the data is built in a way where it can be shared out to CIFS or GeoJSON, and it's CIFS compliant. And there are like additional fields that we have added, but it doesn't sort of break the format of CIFS in the first place. So like if you're consuming that information, you would just drop the unnecessary things. And the GeoJSON format as well is sort of the same thing. It's a lot of the same information, just formatted as GeoJSON. So that's sort of the application as a whole. I now want to talk about sort of how it was built. So like talking about the stack going from the bottom up. It's a traffic cone. I made it in Google Slides, so if anyone has any questions about how to do that, I can answer them afterward. I was very proud of it. So the first thing that we sort of worked on is sort of two things actually. So it's sort of low, so sorry if anyone can't see it, but sort of the bottom level is, in our case, is OpenStreetMap. So if you're unfamiliar with OpenStreetMap, it's sort of it's like the Wikipedia for maps. You can also use your own base map, so it's not like like the shared streets referencing system, which I'll explain in a second. It's not specifically tied to OpenStreetMap, so you can use it with your sort of existing internal data set. That's kind of the whole point. So the referencing system itself, if you want to go to GitHub, you can see it. I think partly there and partly elsewhere. We've got to organize it a little bit better, to be honest, but all the information is there. Essentially what we're doing is we're taking any base map that's presented to us and creating basically an open source road network on top of it. And we're then, I believe we're generating a set of tiles itself from the base map information. So that means that you can do a bunch of different operations on top of that, which we've, or actually, you know what, I'll explain that in a second. Sorry, confuse myself in the order here. I will explain the referencing system in a little bit more detail. So sort of the next thing that's sort of important to know, and this is like kind of the meat and potatoes of everything we do here, is that the referencing system is a shared language for the street. It lets maps talk to each other. And so what I mean by that is often you'll have like this situation on the left, which is like the one I described with the things I did with Asbury Park earlier, is if you don't have maps that match, how do you describe the location of a closure accurately? So you've got two maps that they mean the same thing in the real world, and like when you eventually go outside, you'll be in the same, like you'll be in the place that you mean to be in, but the digital representations are actually not the same. I think the red map has got an extra road that the blue one does not in this case. So shared streets helps data to be exchanged between those two things. So how does it do that? I'll explain. So what we're doing is we're taking sort of the core segment geometry from the base map, and for each street segment, we're generating that geometry. From that geometry, we're generating a longer form intersection reference. And then from that, we're basically just hashing that to create sort of a stable ID on top of that. So the original problem that sort of our founders sort of thought of when they're building the idea out was that OSM has got this problem where like the IDs are not stable, meaning as the way one of my bosses explained it to me was that you can just take, I don't know, you can take 10th Avenue and just drag that specific relation across the world and it would still be the same ID. And that's kind of a pretty big problem when you want to rely on the fact that one ID means one base map, or one ID means one street segment across all base maps. So this is sort of the way we think about how to solve that. And just to visualize it again, since it took me a really long time to understand this, is if you've got your sort of original map, and you've got a reference ID for sort of this map in red, you add your second map, which is the blue map, map B. It's the same street, it's just the representations are different. So the nice thing is that we know both IDs are the same. So once we've run both base maps through shared streets and sort of generated a reference base map, we now know that, okay, no, even though that like the core geometries are different in these two maps, the IDs are the same. So that means we can share data across both maps. So if we know that for some reason we've got sort of a speeds data set for map A, and it says that this segment is 35 miles an hour at average, we can infer that map B has got the same thing since the IDs are consistent. So we encapsulate a lot of the kind of functionality that's sort of the usefulness in a library called SharedStreets.js. You can just run npm install SharedStreets and sort of get started. What we offer right now is line matching, and point-to-line buffering. So basically just sending in arbitrary like GeoJSON information and getting back a matched version. And that's pretty much how I built my application on top of that, the one I demoed earlier. I just took the APIs, and when you sort of draw in a road closure, and I'll just go back to that just to sort of edit the video back here. So as I do so when I click search, it's actually matching to the shared streets referenced tiles and getting back that street segment with that ID. With the, I guess in this case, it'll probably be 3 distinct segment IDs, but they all show up, and yeah, and that's sort of it. That's kind of how everything happens. The sort of like neat thing here is that I work on like our applications. So I'm primarily like a JavaScript person, which if you're unfamiliar, I really I didn't do too great in my like computer science theory classes. Not as good as I could have probably. But to sort of group some of this information together, I actually got to use a depth first search for the first time since I graduated like my computer science degree. And that was kind of made possible due to the fact that in like this example, every street segment you see has got a unique ID associated with it, and it actually got sort of like the intersection it's going to and the intersection it's coming from. So this is not that like exciting, I guess, for most people. And if you think about it for 2 seconds, it makes a lot of sense. But for me, it was pretty exciting because I got to sort of leverage something. I can immediately see the usefulness of having sort of like this referenced street network. And I'm pretty new to like a lot of like geospatial and sort of city data stuff, so that was very cool to me. But yeah, that's pretty much it. So I guess I don't know if I have any time for questions, but I included a slide saying that I do. So hopefully.